Alright, as I'm verifying this identity, I take a look at it, and I know that I'm supposed to start with the complicated side, but really neither one of them looks more complicated to me. Doing these for a while, what you will start to realize is that if anytime we have a fraction, I would probably start with the fraction side, to be honest. I think when I look at it, after doing these for a long time, I think that it would be easier to work with this side and to simplify it down and turn it into something that's not a fraction. So the question is how do we get rid of the fraction? And the answer is, and if you watched this in a previous video, the answer is if we have 1 minus sine x on the bottom, we're going to multiply by the conjugate of that. We're going to multiply both the top and the bottom by 1 plus the sine of x. The reason that we do this, if you didn't watch the previous video, the reason that we do this is because it's going to become clear in a second. We've got a difference of squares on the bottom, right? So I'm going to have then secant x plus tangent x. I'll leave that like it is. And on the right hand side, I have cosine x plus cosine x sine of x. So I distribute the cosine, right? On the bottom, I have 1 plus sine, 1 minus sine. And so that gives me 1 minus sine squared of x. Alright, a little bit closer, right? Here we go. Secant x plus tangent x is equal to. Now, what can I do with this? Well, I'm going to leave the top like it is because I'm not really sure what to do with it. But the bottom, I see 1 minus sine squared. So I come over here and I say, alright, here's what I know. Sine squared x plus cosine squared x is equal to 1. I need a 1 minus sine squared. What is 1 minus sine squared? How can I replace that? So if I take the sine squared and subtract it from both sides, turns out that 1 minus sine squared of x is the same thing as cosine squared. So I can replace the denominator on the right hand side. Now I have secant x plus tangent x is equal to the top cosecant plus, or excuse me, cosine plus cosine sine. The bottom now though, oh, I already wrote that. The bottom is cosine squared now. Glad I wasted all that space. So I guess we'll get rid of that, huh? Alright, now with that in mind, I see now two separate fractions here. I'm going to break this up because there's only one denominator, right? So the first fraction is going to be cosine over cosine squared. The second fraction is going to be cosine sine over cosine squared. And we're going to see that those cosines start to cancel out, don't they? So I have on the left secant x plus tangent x. Hope I have room now. The right hand side, I have cosine x over cosine squared of x plus cosine x sine of x over cosine squared of x. Now just like this, look, I have first power over the second power. So one power goes away. I'm left with, I've got to write this, secant plus tangent is equal to, I have 1 over the cosine left after 1 power of x goes away from the first fraction. On the right hand side, I still have the sine left over on the top, but then I have cosine over cosine squared, which whittles down to 1 over cosine, right? 1 power of cosine goes away. And what do you know? Look at the left hand side. 1 over cosine is the same thing as secant. And sine over cosine is the same thing as tangent. And I've just verified the identity. So the trick on this problem, going back to the beginning, is start with the side that has the fraction. That's probably more complicated. And multiply the fraction by the conjugate. If you have 1 minus sine x, multiply by 1 plus sine x, create a difference of squares, because when you create a difference of squares, it typically ends up being one of the Pythagorean identities, which means you can replace 1 minus sine x squared with cosine squared, and that's the idea. Let's try it again over here. Looks a little bit more complicated. Once again, we probably want to start with the side that's a fraction. I'm going to multiply both the top and the bottom of this fraction by 1 plus cosine of beta. So the left side is still cosecant beta plus cotangent beta. The right side is now, I'm going to multiply, I'm going to distribute out the sign, So I have sine beta plus sine beta cosine beta. On the bottom I have 1 plus cosine, 1 minus cosine. That gives me 1 minus cosine squared beta after I FOIL that out. If you need to FOIL it, if that doesn't make sense to you how I change the denominator, you should go through and actually FOIL it out. Just do first, outer, inner, last, right? Okay, so if I have cosecant beta plus cotangent beta, I can replace now 1 minus cosine. I'm going to focus on this, right? I'm going to focus on this. So if I have sine squared beta plus cosine squared beta is equal to 1, and I want to know what 1 minus cosine squared is, it looks like I need to subtract the cosine squared from both sides. I end up with sine squared beta is equal to 1 minus cosine squared beta, right? So that means I can replace the denominator on the right side with sine squared. Numerator doesn't change. But the denominator is now sine squared. So now I see, once again, I see two fractions. The first one is sine over sine squared. The second fraction is sine cosine over sine squared. So I'm going to go through. I've got to rewrite the left side here. And the right side I'm going to break up into two fractions. Okay, first fraction turns into sine of the first over sine of the second. 1 power of sine cancels out. I'm left with 1 over sine. Second fraction, I see that I have the cosine here on top. And then as far as the sines go, sine over sine squared gives me, once again, 1 over sine. So 1 power of sine goes away, right? I could do this if I wanted to. And what do you know? 1 over the sine is the same thing as the cosecant. And cosine over sine is the same thing as cotangent. The verification is complete.